Let me just quickly introduce myself. My name is Radek. I'm a technical recruiter at JLabs, and I will be your host today. So before we start the main part of our event, let me just say a few words about how it all came to be what it is today. Um, we started with our meetings in 2014 by the name of IT Academia JLabs. At first, the lecture was focused mainly on students, but then we transformed it into a full-fledged IT event for experienced developers. What you should know is that we invite renowned speakers to talk about the main trends in IT to around 1,000 participants a year. So Talk4Devs is here thanks to JLabs and our people that wanted to create a space to share knowledge. So for those of you who do not know us yet, JLabs has been operating in the IT outsourcing area for over 12 years now. It has been providing its services for 40 clients in 3 locations with around 300 engineers on board. We hire whole teams and individual programmers who take part in development of the award-winning software for companies from several sectors, such as banking, telecom, logistics, e-commerce, and many others. We specialize mainly in Java and JavaScript programming languages. So I think it's high time we moved on to the main part of today's meeting. Just for you to know, we'll have a few minutes for the Q&A session at the end of the talk. So please remember to use the Q&A window to write down your questions and vote for them. Nir, are you ready?
Yes, I'm ready.
Great.
Yep. All right. I'll share my screen and we can start. Just a second. I need you to.
Yeah, I'll stop sharing mine.
Stop sharing.
Sure.
Let's see. And yes, can you just approve that my screen is shared?
Yes, it is.
All right. So hi everyone. Very happy to see so many of you here live online. It's not obvious, so it's going to be fun. Remember to prepare your questions because I'm here to share my knowledge. I know we don't have too much time, but I'll do my best to share with you as much as I can and answer as much as question as I can. This way or another, you will be able to keep in touch. So let me introduce myself quickly because I want to jump right in. My name is Nir Kaufman. I work in a company named 500 Tech, where we specialize in front-end development for the past almost 8 to 10 years. I'm also a Google developer expert for Angular with Math technologies. And yep, and traveling around the world currently virtually and sharing my knowledge and learn from others. And that's the reason I'm here. Thank you very much for JLabs and all the organizers that they're involved of invited me here. Very excited. You can get in touch by visiting nir.life. You get links to the slides, to the code, and you can keep in touch via Twitter. Check out other meetups that I'm organized around the world. I'll share this slide later. So if you like to give it a try, currently everything is online. So you will be able to participate each and every meetup wherever it is. The topic for today is going solid with Angular. But before I jump into the slides, I want to create an Angular project from scratch. So I'm going to run npx ngnew, and let's give it a name. Let's call it solid Angular. And I want it to be a minimal project. So while I'm doing my introduction, let's generate a project and try to build something from scratch. Worst case scenario, you know, live coding is not always successful, but let's focus on understanding what's going on. What you see currently in these slides is, I think, is, I believe, the most important concept in software development, generally speaking. We're trying to aim to write a software which apply the concept of being loosely coupled, but on the other hand, high cohesion. So let me explain it with slides. All right. So we're building a software. It doesn't really matter right now if we're talking about front end, back end, whatever. We building a piece of software. Especially if we're working with Angular or JavaScript or many other languages, our software is composed by a bunch of units, classes, or objects. Each object encapsulates some data and relevant method that related to this data. So we've got a lot of objects, and we usually package those objects together to perform something very specific. So when we build a feature, this feature is a collection of objects. And our goal as developer is to keep our object loosely coupled, which means that they should be as less dependent as possible on each other, which means that each class, each object, each instance should know as little as possible about other objects, but all of them together in the context of a feature should work together as a unit. And even the unit itself should be loosely coupled for other units. So we take this principle to the object level and into the package level. So if we successfully apply this idea of building a very complicated software by introducing objects that know as less as possible about each other object, packed together in modules or packages or features that know as little as possible about each other, good things gonna happen. It's gonna be much more maintainable. It's gonna be easy on us to introduce new features. It's gonna easy on us to refactor, to test, and generally speaking, to extend our software. So the principle of least knowledge is talking about how much knowledge each unit, and I'm using the term unit and not an object because it can be a module which compose of many objects, and it can be a single object. How much knowledge each object, each unit knows about the other. And obviously we're gonna try to minimize it as possible. Angular make it very easy, like we're gonna see in a second. The next thing that I would like to talk about in this introduction before we jump into the code is the SOLID principle. SOLID stands for 5 principles that are associated with object-oriented programming. Now, I know that there is some kind of argument about JavaScript as an object-oriented language. Is it a pure object-oriented language? Is it not? But the bottom line, and as a fact, is it doesn't matter how you create your objects, whatever it's a function, a JavaScript function, whatever you use TypeScript. So you got this synthetic, class and interfaces syntax to be more precise, or you use a plain JavaScript class because we can do it, or if you even just literally define your object. By the end of the day, we've got objects. So the SOLID principle, although they were created and associated with more classical object-oriented programming languages where you have to define a class, otherwise you can't create an object, is very relevant to JavaScript and to our code, even if you work on a single page application on the front end. Sometimes people think that those principles and design patterns are related to all technologies, but that's not the case. So I want to go quickly explaining those principles. And I'm saying that I'm going to do it quickly because we're going to start writing some code, or like at least looking at some code, and then it will be much more obvious what it's mean. So the single responsibility principle says that each class should have one and only one reason to change. That's an easy way to think about it. Think about your project, think about your code, think about your day-to-day work. If you need to refactor, let's talk Angular, for example, but it doesn't have to be Angular. If every time that you need to refactor a single line, on a class definition, constructor, function, whatever. Let's talk classes on a class. And because of this, and you have more than one reason to change this class, you are violating the single responsibility principle. Let's say that your class is responsible for two different things. For example, making API request, but also to rendering something to the DOM. So you've got two reasons to change the code in this class. One of them is if you need to change how you make API calls, and the second, if you need to change your presentation logic. Angular make it very easy because we're getting some kind of good best practices out of the box. But we're gonna talk about it more in a second. The open close principle, I think it's the most important principle, generally speaking, and specifically when we build UI components. But not just UI components, as we're gonna see in a few minutes. The open close principle means let's write our code in a way that if I'm gonna need to extend it, to extend how it behave, I wouldn't need to change the source code, which means in an ideal implementation, you write your code only once, and then you can extend it without revisiting the code, the source code that you are extending. For example, you build a component, a UI component, and you want to be able to extend its behavior. And ideally, you want to get some kind of API or a coding technique that enable you to change how the component behave, but without changing any line in the original component itself. So that's the open close principle. Every unit, every class, every object should be open for extension, but closed for modification. This one, I'm gonna walk over it very quickly. The list of substitution principle talk about, yeah, it's a hard word to pronounce if you're not a native English speaker like me. Talking about basically creating small interfaces, very focused interfaces instead of I'm trying to talk and code simultaneously. We've got a project, so I'm going to explain this Liskov substitution principle, but just showing you a piece of Angular, and everything going to be much more clear. So let's open the project that I just created, which is, I don't remember even where I put it, but I can do this and find out where is it. Here is it, solid Angular. All right. I'm using the latest version of WebStorm, and it was just updated, I think, right now. So it's yeah, it's giving me some hard time to navigate, but don't worry. I just think I open up the wrong version of it. We call it solid Angular now. Yes, it is, and here is everything. Go ahead and open it. If that's not going to work out, we're going to switch to VS Code. Hopefully we won't need to do it because we are fine. Cool. So what is this Liskov interface segregation principle? All right. Talking about this one. Object of superclasses should, oh, sorry. I was confusing with two principles. What is the Liskov substitution principle? This one is easy. If you create a base class and you've got a bunch of classes that inherit for it, they should be replaceable with each other. So if you got some code that depend on a specific class, if you replace this class with any of the subclasses, your code should still work. You might ask yourself, is it relevant when we're talking about Angular? Well, the reason that I'm just explaining it very theoretically is that in Angular, usually we are not extending objects. It's not very popular to create inheritance trees, but personally, I found a lot of scenarios where I do write some components, UI components that extend each other. So the principle in a very simple manner is if you've got a hierarchy, you should be able to replace the base class with each subclass without breaking your code. Think about it. the principle that I wanted to show you some piece of code and explain it, called the interface segregation principles, all right? The I in solid, which basically mean create small and focused interfaces. And the easiest way to explain it is just show you some Angular code. So if I open up this app component, and I think we're all familiar with, I just generated a project from scratch. So let me clean it up a little bit. And let me create here, let's create an H1 saying solid Angular, all right? And we don't need this. So what does it mean? The interface segregation principle. It means that every time you need to implement a specific lifecycle method in Angular, for example, you use a very focused interface like the onInit interface, all right? Now, if you look into the onInit interface definition, it's gonna look like this. The onInit got only one method, ng-onInit, and that's it. And this is an implementation of the idea of creating small interfaces, because we don't want our class to be exposed to a code that it doesn't need. Think of the alternative. Let's say that we had an interface called life cycle. And in life cycle, we're gonna have on init, but we're also gonna have after init, after view init, and we're also gonna have, let's say, on changes. And let's say that in Angular, you have to implement the interface lifecycle. Got a typo here, all right? Lifecycle. In this case, you'll be exposed to all the methods that this interface suggests, even if you don't need them. So it's either you have to implement them all, or you start doing stuff like this. This is optional, and you know, technically each one of them is optional, because I might need just the onInit in this case. Now, if you create an interface that most of its content is optional, think about the interface segregation principle. Just create small interfaces and focus interfaces, so each one of your classes can implement exactly what it needs, instead of implementing an interface that got method that it doesn't need. So that's the I in solid. And the best way to explain it is just show you how Angular actually implement this idea and created small and focused interfaces. Cool. The last one, dependency inversion principle. No, we are not talking about dependency injection, although you're going to see that DI in Angular help us achieve this. But the dependency inversion principle, which is the majority of the code that we're going to see in a second, talking about that your code should be depend on abstraction and not concrete implementation. So your components should inject interfaces, abstractions, and your low-level services should inject or should depend on abstraction. And your business logic should be the concrete implementation. Because if you write your Angular code in a good way, if you align with the solid principle, specifically with the dependency inversion principle, it means that your component works again an interface, and theoretically, it should never break. Because whatever the implementation gonna be, if it's bind to a specific interface, your code gonna work. It's not gonna fail. So I talked too much, and I know I went through all the solid principles really, really fast. But now I want us to look at some code and talk about how this code apply, or how do you write a feature in Angular that communicate with those good software principle ideas. I just want you to remember a second before we jump into the project, the important concept. Program to an interface. Write your programs, write your business logic, write your UI component against an interface. Leave the concrete implementation to a very specific layer of your app. All right, we're gonna see it in action. So that's enough for the slides. Let's jump into the code. and let's start to see something. So I want to build a feature. I want to build a feature which is, I think, is a very popular feature. First of all, I'm going to do npm install Bootstrap because I want to things to look a little bit more nice. I mean, CSS, that's not our focus. Meanwhile, I'm going to do ng-serve. You know what? I'm even going to do ng-serve. I think it's open. And then it's going to serve, it's going to open the browser. So it saved me another step, all right? This one is not necessary anymore. And I think that we've got Bootstrap installed, which is cool. So I can go ahead and go to style CSS and just do an import of, right? Failed to compile, obviously. Import of Bootstrap, dist, CSS, Bootstrap CSS. So now we've got Bootstrap in our project. And if I come back here, you can see that we've got a solid Angular app and all good. So I want to implement a feature. And the feature that I like to implement is basically, I want to show a message, a pop-up message, every time there is an API error. So if that's the case, the first thing that I'm going to do, I'm going to go to my app component and I'm going to quickly sketch how I want it to look like. So the template is going to look like this. All right. It's not super fancy. Let's call it solid Angular. And basically what's going on here, I've got a button group with three pieces of code. Each one of them going to generate something from the server. This method is not implemented yet, so I'll show you how it looks like by providing some content into this class. All right, let's walk here step by step and see what's going on. Generate code is not important for our topic. We're looking at runtime. We're looking at the app component, how we're going to use the thing that we're going to build. So this component currently make an HTTP client call. This one is not important right now. All right, so let's skip it. And let's see how it looks like. I'm commenting out some code because it's not important yet. All right. What I want you to see is that this HTTP client go to a specific service and I'm going to get some different 200, 400, 500. Let's see how it looks like. All right. So I'm going to open up my dev tool. I'm going to hit the network. And I think we've got a compilation error. It can't find the HTTP client, which makes total sense because here I didn't import the HTTP client module, right? And now everything should be okay. So let's see what's going on here. I'm going to go hit the network. I'm going to make it a little bit larger. Generate 200. It's a API call, which going to return hopefully 200. Here you go. All right. And generate 404 should do the same thing, but eventually going to return me 404. And generate 500, going to make an API call. It's going to be pending, you know, sleep for 2 seconds and internal server error. So I started from the top. Now, remember that I talked about the concept of implement to an interface and not to a concrete implementation. When I'm starting implementing a feature, I'm always starting by defining types, by defining the interfaces. And only then, I'm going to start by defining my interfaces, and then I'm going to use those interfaces, and then I'm going to supply some concrete implementation. Let me show you how I do it. So the feature that I want to implement is every time I want to write an HTTP interceptor, and every time there is an error, an API error, eventually I want to display a toast message. So I'm going to have some piece of UI that show you a message. I'm going to have an HTTP interceptor that actually intercept the API request. And I'm going to have some kind of business logic, so a service that know how to manage those messages. Which means that I'm going to start by introducing a module. Because if I've got a bunch of classes, a bunch of units that need to act in cohesion and create one feature. In Angular, we pack everything inside a module. I'm going to call this module central messages. And the first step, at least what I'm doing, is creating a file and call this file, it's not even an Angular file, yeah? And I'm giving it the same name like central messages types. Because everything starts by defining some types. So let me paste in some code that I prepared for you and let's talk about it. First of all, I'm thinking about my feature in an abstract way. I know that I'm gonna have different types of messages like error, info, and success. So I created an enum. Then I want to sketch how a message look like. So a message got a message type and it's got some description. Next, I want to be able to log some messages. So I created an interface that describe how a message logger look like. If there is a class that know how to log messages, what's going to be the structure? So a message logger going to have a method log messages. It accepts a message of type message. It doesn't return anything. This is an interesting part, all right? In Angular, if you're working with Angular for some time, you probably know, hopefully you know, that you can't inject an interface. But I want to be able to inject this message logger, but I don't have any implementation yet, because remember, I'm building my software against an abstraction. I don't know how the business logic should look like right now, and I don't care in this point of time. So I created a new injection token, a key that I can use. I'm passing an array of message loggers, which means that this key, if I'm gonna inject it, it's gonna return me an array of message loggers. So everything here is purely abstract. Last thing, I want to create a configuration for my central message logic. So I want to describe how it looks like. I highly encourage you, every time you step into a feature, start by sketching interfaces and abstractions of what you're going to build. All right. Now, actually, I've got enough to implement my app component, even the client, all right, without even know what's going on. Let me show you. First of all, here on the app component, I know I'm gonna need a service that know how to handle messages, all right? But I've got a type for it, all right? The central message service, all right? I know how it looks like. Let's see how it looks like. Actually, I haven't created it yet. You know what? Let's create it. Let's create how an abstraction of how this service is going to look like, because I don't know what's the implementation. I want to keep everything abstract. So I'm going to create here another file, and I'm going to call this file, let's call it central, or you know what, even better, let's call it abstract central message service. No, it's not even a service, just a TS, all right? Let me paste some code there, because now we're going to describe how it looks like. I want you to look very closely of this code. Everything here is still super abstract. I've got an abstract class that defines some kind of a service. I know that for a message service, I'm going to have a message queue, all right? I know that I'm going to have some internal stream of messages. I don't know how the set message look like. I know it's going to accept a message. I don't know how the remove message look like, but I know it's going to accept a message, all right? I'm still in abstract land, because now I can come to my app component. Did I forgot to export it? No. And I can do this. Inject, abstract, abstract, come on, abstract message, central message. All right, here you go. And I want you to see something, which I think is beautiful. Look at this app component right now. My app component actually contained the business logic that I wanted to implement, but without providing any implementation whatsoever. My app component depend on abstract central message service. The abstract central message service is, like the name suggests, is abstract. It's got no logic in it, all right? But still, my app component can work against it. Same for the message. The message itself is an interface. I don't have any messages. So right now I've got this app component with all the typing that I need. In a real world application, I wouldn't even inject the HTTP client because it's a concrete implementation. I would go ahead and just inject some abstraction. But the important step that I wanted to show, it maybe the most important step before I move forward, is to show you the concept of when you start working on a feature, it's very, very important, easy, and makes sense to start with defining a bunch of abstractions, like all the types. You already know which kind of messages, maybe. You at least know that you're gonna have different types. To define all the abstractions right ahead, and only then go ahead and use them. What Angular developers usually do is writing some components, some logic, and then inject some concrete classes like real implementations, and then go ahead and few rounds of refactoring, replace it with more generic code. All right. Now I'm going to stop the live coding right here because unfortunately we have only 45 minutes. Don't worry, we're not done yet. We're not even close to done, but I'm going to show you the end results, which I'm going to share with you later on. All right. So I'm going to start from scratch. This is the complete feature implemented in Angular, aligned to the solid principles. What I'm going to do now for the next 10 minutes is walk line by line with you, explain you about all the moving parts, explain you why this feature is implemented aligned with the solid principles, and show you how it actually works and why it's so important. All right. So let's start with the app component where I use it. So just like before, what we started to do in live coding, which was very important to me to show you, the app component is depending on some central message service, HTTP client, making some calls. That's cool. Actually, I want to change it to abstract message service, but that's not the point right now. Let me bring in the terminal and call ngserve with open and serve this project. I'm gonna take a second. All right. Everything related to my central message is packed inside this module. But now the fun part begins. First of all, let's see how it works. Let's see if it works. If I click generate 500, do I get a message? No, something broken, maybe, maybe not. Maybe the network didn't work. Let's see. 500 sleep. Here you go. Something bad happened. All right. So I've got some feature that works. Let's explore the moving parts, and I show you how I implemented this and how it aligns with the concept of open close principle and other principles that I show you into introduction. I'm going to start from here. This is my app module, and my app module want to use the central message. My app module want to use the central message module, where you can see right there. All right, let me fold this. And the central message module, the way that it's implemented, looks like this. First of all, you can load some configuration. I'm going to show you why it's important in a second. So I've got a app initializer, which is coming from Angular, and I hooked in a function that can load configuration from a JSON file. And it's going to happen when the app is in it. This is not my own code, but it's interesting because look, the Angular framework itself is open for extension and closed for modification, which means that I can add logic to the process of app initialize without the need to go ahead and refactor Angular code. Think about it. Next, I'm providing HTTP interceptors. So here I've got this interceptor that go ahead and catch HTTP requests and set a message. But look at this, my interceptor inject the abstract central message. So it doesn't know how this service look like. All right, let's go back to the module. Next, so here I'm registering my interceptor. Again, I'm extending Angular itself, adding my own interceptor without the need to refactor Angular code. And last, I'm providing the abstract central message and I'm providing some logic. I'm using the key abstract central message, which is an abstract class, and I'm providing an implementation, a default implementation. Let's look how it looks like. This is the default, my default implementation. So I've got set message and I've got actual business logic here, and remove message and I got business logic here. But what interested about this, that if you look at the constructor, you see something very, very interesting. And I want to show you. I'm injecting message loggers. I'm using the inject flag because message loggers, if you remember, it's not a concrete class. It's just an injection token which use an interface, which means that my code right here, right now, which is the central message. That's the reason I don't really like Visual Studio Code. So excuse me, feel a little bit clumsy. All right, which means that my central message service depend on an interface. I injected an interface. He knows that optionally it's going to get an array of message loggers, which is an interface. It doesn't know even if it exists. That's the reason it's optional. It doesn't know what is it. It's not concrete. It's an interface, and I'm using it right here. You see, every time you've got an error, if you've got an array of message loggers, go ahead and use them. So my service inside my modules depend on abstraction. My module itself, all the moving part in my modules depend on abstractions. Very, very important, which means that my interceptor depend on abstract central message. The component itself that show the message, let's look at it. Let's look at the component that actually show the pop-up. And let's look at the constructor, depend on abstraction. When you build a shared module, when you build a module in Angular that you want it to be extendable, but without refactoring the code itself, by applying the open-close principle, the program to an interface principle, the even more than this, the dependency inversion principle, which means basically in simple words, each one of my classes that are part of this module depend on abstraction. There's no implementation here. All the moving parts, the service, the component on abstraction, the interceptor on abstraction, everything depend on abstraction. The module itself, the central message module itself provides some default implementation. So the code will work with this default. This is the only concrete class, yeah, that actually holds some logic to how to show messages. So that's the only point where I actually provide some configuration. Now, when you look at this module, central message module, I'm going to tell you, all right, so you've got here a nice module. If you take it as is, let's say you want to use it in your app, not mine, all right? You can just inject it. You can just inject it, and it's probably going to work. And I want to prove it to you. I want to delete this array of providers that you see here, and I want to show you something. If you want to use my central message module, go ahead, import it, and magic. Let's see if I'm right. I just imported the module, and that's it. I expect to see something happen, and it is. Now, when you write your modules, and a lot of developers that I meet say, well, that's the beauty of Angular. You can just drop in a module and everything works. But we want to build our code aligned to the solid principle, and more importantly, to the principle of open close. Now I want to be able to take this central message module and extend his behavior, but without touching the central message module itself. Let's see how I can do it. So in my app, I want to provide my own message logger, even more than one. So I created two classes, message console logger. I'm implementing the interface, all right? The message logger interface, and log message. And I implemented another message logger. Implement the message logger, log message, and this one gonna send to server. Now, if you look at these classes, you see that I'm aligning with the single responsibility principle. Each one of these classes is focused, has only one reason to change. If you want to change the way that you log to the console, you're gonna mess with this class. This class doesn't know anything about other classes. It's not dependent on other classes in this use case. And it's very, very focused of what it's doing. So my loggers don't know about each other. But look how beautiful it is right here. In my app module, in my app, I want to provide my own message logger. I want to provide more than one. I can provide 100. I've got my own implementation. So I can create loggers and just use these key message loggers, provide my own implementation. Let's see how it looks like. Let's see that I decided to add one logger. I'll go back to my app. I look at the console. Let's generate 500. And let's see what's gonna happen. My custom console logger logging something. Now I want to extend my module without touching it, so I can add another one. This is how Angular helps us to implement the idea of open close principle. Look what's going on. I'm extending the behavior of my service because my service inject message loaders, which is an interface, but I'm providing, when I say the user provide the implementation, and that's the power of dependency injection. And this multi-true means that I can keep adding loggers. Now I added another logger because I want to log to the server as well. So I click 500 and let's see what's gonna happen. Yep, my custom console logger and send to server, which is cool, but that's not enough for me. I want, you build the central message module for me. Nir built a beautiful interceptor to show you messages. And it's got some default behavior. But let's say that I don't like the default behavior. Let's say that I want to take it a step further. In my app, I want to use Nir module, but I want to build my own custom message service. Every time you add message, I want to do an alert. Can I replace the behavior of this encapsulated module that Nir created? Can I affect how central message module works entirely without touching it? Is it open for extension but closed for modification? Yes. Why? Because the creator of the module gave me this abstract central message token. So in my app, I can override it and register a custom implementation, custom message service. So what's going to happen now? Same module, I haven't touched it, but now I expect to see an alert popping up. And here you go. Which means that I created my module, but I gave you as the user, the consumer of my module, tokens, injection tokens, and I implemented my module internally depending on interfaces and abstractions, and you as a consumer can use it as is. You see, when I remove the providers, you get a default behavior, but you can also extend its behavior. You can provide loggers if you like. You can even create your own message service completely custom and provided. And you're doing it without even open my module and interrupt with it. But that's not enough for me. So I'm going to finalize this talk with taking it a step further. So each one of the classes inside my module implemented by the solid principle. Single responsibility, small classes, doesn't know anything about each other. The interceptor doesn't know anything about the concrete service, message service. The component that showed the toast doesn't know anything about the interceptor. So I implemented the single responsibility. I've got a lot of classes that not just focused on one thing, like the alert gonna show the loader and the interceptor gonna intercept. Each one of them is very specific, or it's got only one reason to change. It's also implement the least knowledge principle. Each one of these classes doesn't know about any other class. They all know about these abstractions that I created. So each one of the internal classes in my module, and you're gonna go through the code, I'm gonna send you a link, you can see that it's implemented in a way that it's so abstract that if you use it, you can override and extend it without even know what's going on inside of it. It's like a black box, and that's the beauty. But that's the module. Now I'm greedy. That's not enough for me. I want to build this project. So I ran ng build, all right? I already did it, but you know what? Let me do it again. I ran ng build. I'm gonna build this app. It's gonna end up here in this folder called this. This is the last example, and then I'm gonna summarize. Let's wait. That's it. All right, so now I've got my app ready for deploy. Now I'm gonna serve this app from the dist folder, which means my application is compiled. That's it. No more runtime, all right? No more providing implementation during the build phase. It's compiled, it's out there, it's in production. Let me serve it. Let me do npx http server. I need to go into dist, I think. And let's see if it works. All right, cool. Open, yeah. Now this is in production. This is almost in production because I've got another level there. It's not just this, is this, and the name of the project. Now I think it's gonna work. Let's see. Open. And again, here you go, all right? So I've got this in production. And every time you generate a message, you're gonna see a console log. This is my custom implementation. And you know what? I'm not even seeing a console log. Now, let's see that I want to enable logging. So I want to affect how the app is working on runtime, but I don't want to open the source code and change something. I want to change the behavior in runtime without opening it up. So I took the open close principle a step forward. My entire app built on production, but it's open for extension, or at least open for configuration. The only thing that I need to do without rebuild my app while it's still in production, I've got a static file called central message config JSON. I'm gonna change the enable loggers to true. Please enable my loggers. And that's it. If I refresh now, you see, I've got logs right here. And if I go ahead here to this simple JSON and change it to false and refresh, you don't see any logs anymore, which means that my app is in production, running live, and I want just by changing a static JSON somewhere to enable loggers or disable loggers, which means my whole app is open, enable me to change how it's behave in a very interesting way. It's possible because the way that I build this module is going to read this JSON, and you know, if you look here at the network, you're going to see that the first call is for central config JSON. A very interesting scenario. So let me summarize and then answer some questions. First of all, the solid principles in a nutshell. We aim to write our software in a way that it's open for extension. It's easy to us to extend it, but we want to be able to extend the behavior and affect the behavior of our code without the need to actually go ahead and refactor the source code. Now, it's become even more important when you build Angular apps and you build reusable components or reusable modules. When you build pieces of your Angular app that's going to be reused in different places, but each one of the consumers might want to configure it a little bit different or provide its own custom behavior. So by adopting this whole approach of a program to an interface and created an API that eventually let the consumer decide how we want to use my module, like I showed you right here, each one of you can take my module right now and provide its own implementation, and without even the need to go ahead and open it up, I can even build it. All right, that's our goal. Angular make it easy because Angular give us injection tokens, and Angular is written with TypeScript, so we can use abstract classes. An injection token let us inject interfaces, and the module itself give us the providers that we can override those injection tokens. And even Angular itself give us the option, this is the code that you see right here, you see, to intercept with the initialize process. And right here, I'm loading configuration from a JSON files that exists on assets. So even after I build my app and it's running, I can still, it's still open for some modification, open for extensions. I can affect its behavior without even the need to rebuild. So that was it. It was just 1 hour, I know. There's a lot to talk about, I know. I wish I had like 4 hours to talk with you about it, but that's not the case. I really, really hope that I'll share this code with you, the link, obviously. I hope that it's opened up your mind a little bit. First of all, to how the solid principle is a great guideline when you build your infrastructure with Angular. And second, I hope it's open your mind and like show you an approach of how we can literally write our code against abstractions and what the benefits of this. I hope I was able to teach you something new. If you learn something new and you want to tell me about it, just do a like in the chat. I'm going to see it. I'm very, very curious. This way or another, I'm going to share this code with you. You can feel comfortable to contact me via email, Twitter. You can find all of my details in nir.life or just Google my name. And I don't know, do we have some time for questions?
Yes, we do. So can you see the questions, the question and answer section?
Yeah.
Okay, so I will just ask you to read them aloud before you answer.
Of course.
And for you all, if you want to post some questions yet, now it's the time to do it.
Yeah. So will the code produced during the webinar available somewhere in GitHub? Yes. And I'm going to share the link with the organizer and I'm going to share the link with all of you. Actually, you can do it right now. I mean, go to my repo. You can find my repo and all the code examples. If you visit nir.life, this is my simple webpage. You see here the link to my GitHub. So it's easy to, I mean, it's easy for me because that's my name, to remember nir.life. But if you look at the repository, where is it? Talk4D. Here it is. I'm going to take it right now. I'm going to type answer and put it right here. You can copy it or find it later. So that's the first question. Is it there? I don't know. What is answer live? Oh, I'm playing with this. All right, cool.
Yes, it's here.
Yeah. Cool. If you're working on an existing project, let's say 70% completed, that has different coding designs, typical code, you ask to do it. Yeah, how to do it? All right, let me repeat it, but shortly, because I read it fast, because I think about it fast. If you've got a working existing project, which means you can't mess with the code, all right? If I understand it right, you can't refactor existing code. How would you try to write a new feature with abstract behavior or change the whole project custom? If you can change the project, if you can refactor it and make it more abstract, that's cool. But if you can't, for example, I'm going to show you a very good example. Let's talk about the window. We've got the window object. We clearly, the window object and all of its method, it's not up to us. It's implemented in the DOM. I want to be able to treat it in an abstract way. I'm going to write code in Angular that looks like this. New window equals new injection token, all right? And here you can provide the window interface that it actually exists in TypeScript. And this is a token for window. And then I'm gonna say that it's that this one is provided in the whole platform. And I'm gonna give it a value which is gonna return the window. Let me reformat it for a second and explain what's going on here, right? I created an injection token that take a third-party code and hide it behind an abstract injection token. So now when you use inject and use inject window, you're gonna get the window as default, but it's very easy for you right now to supply any other implementation for it, because it's just an injection token that wraps something. What I'm trying to say, if you've got a pre-existing code and you still want to create some kind of an abstraction layer, you can use injection token and you can provide the third-party code as a default value, and you can work with the injection token and then enjoy all the benefits of overriding or replacing the behavior in real time. Ideally, refactoring will be the best option if you can. All right, we answered about it. What's the best way to swap global services dependencies during Angular runtime? Great question. If you go through the code that I just wrote, you see that I used an injection token coming from Angular called the app initializer. You've got several tokens that Angular provides you that enable you to replace and configure some stuff during app initialization. I will never learn to say this word correctly in English. Forget about it. During app init. Right now, as you can see, I'm loading a JSON during the app init, and then I'm using this service to use this configuration, which means that by using the same technique, during runtime, you can write some code that even goes to the server and gives you some static code. Let's say that you want to, I don't know, get class definition and create instances, or basically do whatever you want. But the approach would be to hook into Angular init process, provide your own logic, because this code gonna run before the dependency injection kicks in, before the components being instantiated, and that's your chance to replace some logic. And there are several other tokens that you can use in order to do something on runtime. Just take my code as a reference, because during runtime, I'm affecting the configuration. This service, configuration service, loading a JSON during init, and then the logger, my app logger, I'll show you how it works. The service, the default message service, you see it's inject the loggers, inject the configuration, and then use the configuration. So I loaded the JSON in runtime. You can take the same approach, the same pattern, and actually initialize your app in a different way during runtime. Just create a separate file that know how to configure it. Another approach is just a JSON, yeah? Sorry, it's just a very important question. So I think all of us can get the benefits. Look, my JSON currently do this, but easily I can do like, let's say I've got some API service. I can provide here a name. It's a static JSON. Use my API service, my custom API service, and write some code in Angular that if you've got this API service inside your Angular, just want to swap it, you can do it from the outside. Anyway, if you need more details, feel comfortable to contact me via email. Behavior configuration via config license, really cool. I'm thinking if it's possible to extend it to configuration via environment variable to control the application when running in containers. Yes, you can. Great question, easy answer. All right, Angular provides you this ability to like you see right now. It doesn't have to be JSON. I use environment variables a lot of times. All you need to do is use the exact pattern that I just showed you. During app initialize, read the environment variables and use them. Next, what with security connect to the config approach? I didn't deal with security at all. It's a very important concept. It's completely out of scope. Currently, this demo that doesn't take any security consideration whatsoever. The most secure way to actually implement this kind of feature is not using static JSON, obviously, is to use environment variables or just to read the configuration from a remote secure server during app initialization, use those values and forget it. So never use static JSONs like this because anyone, it was just to show you the pattern and just to expose you to the ability of Angular to do to load some configuration. You know, I use the HTTP service to load it, but in the same way, you can do an HTTP GET, go to your remote service, load all the configuration, and then you can also change it during runtime, but it's not going to be with static assets on the client side, it's going to be with static assets on the server. Next, so that was security. And last one, could you share some good resources for beginners about injection in Angular? I can share you the best one, but it's not fair because I created it. I started a series on my channel about dependency injection because I feel there's a lot of things that some people miss. I've got a Hebrew version, but if you speak Hebrew, go ahead. But I've got the same thing in English. Yes, here it is. So a playlist, I'm going to share the link. Dependency injection in practice, the English version. I've got 2 chapters, all right, 1 hour each, that I go through the entire dependency injection implementation in a practical way and explain step by step what is the injector, going through all the API, and chapter 3 is coming up. So I know it's not fair to share my own resources, but I think I did a good job. So I'm going to give it a try. You can write in the comment if you feel something missing. Let's type the answer. Here you go. Good resources. Yeah, I mean, front-end masters got very neat courses. I created this because I feel that a lot of resources deal with how to use dependency injection, but don't explain very good how it actually works, but not very technical. There are some great resources like Angular in depth that go into the source code and explain you very deeply how it works. My series it's like I will explain it, but without exploring the source code too much. Give it a try. You need more resources, please contact me. I'm available and will be more than happy to provide offline. I think that's it, no? If you enjoy it, if you feel that you learned something new, please let me know. Important to me to say. Unfortunately, because of the global COVID-19 situations, I won't be able to visit Poland soon. I will attend this conference like every year, the NG Poland conference. So I will be there, maybe in person. I don't know yet, but virtually for sure. So if you want to check out my talk here, or I'm giving a full day workshop about design patterns with TypeScript, not specific to Angular, but it's probably going to boost your knowledge. So if you want to check it out, and that's it, I think. Yeah.
Okay, Nir, thank you very much for the talk. I think we have no more questions. So thank you all for the questions that you posed. And that's it. Thank you very much for the participation. Just please remember that the video will be available on YouTube and of course on our main page for Talk4Devs. And that's it. Thank you all.
Thank you for hosting me. Thanks.
Great. Thanks.
Bye bye.